Alright, let's work on the second problem of the day. This is LeetCode number 739, daily temperatures. Given an array of integers temperatures that represents the daily temperatures, return an array answer such that answer I is the number of days you have to wait after the ith day to get a warmer temperature. If there is no future day in which this is possible, keep answer I equal to 0 instead. Okay. So, let's see. So we want answer I to be equal to right minus left, such that temperatures at right is greater than temperatures left, and left is equal to I, of course. We know that temperature's length is equal to 10 to the 5. So that seems to indicate an O of n runtime. Let's see. So the naive solution is to run through the rest of the answers until you reach a higher temp or the end of array. And since this will take n plus n minus 1, n minus 2, and so on and so forth, this will be an O of n squared solution, which of course is too slow for a input size of 10 to the 5. Well, what is the repeated work there? Well, let's see. We know that the last element will always have an answer I of 0, and that's because it's the last element, so there's no days to get a warmer temperature. What about the second to last? We just check the next element to see if it is larger. If not, so if it is larger, then 1. If not, 0. Right? How about the third most? So let's look at this 72. Well, that one is fine, right? Because the next element is larger. Same with this one. But what about the 71? This 71 knows that this 69, nice, has a higher temperature within 1 day. However, we don't know what temperature that is. It could be 70, it could be 71, it could be 72, right? And there's no guarantee that the items are strictly increasing, temperatures are strictly increasing. This feels like a dynamic programming problem. That's what I'll say right now. It feels like dynamic programming. though I don't quite know how. So we know that the next item has a solution in which it is warmer, but we don't know by how much. What if we also stored that? So what if we also stored the element which is larger within another data structure? So for example, 73, 74, 75, 71, 9, 2, 6, 3. This returns 1, 1, 4, 2, 1, 1, 0, 0. But what if we also stored the temperatures here that are larger? So we did 2, or indexes. So these are indices of the larger temperature. Then 3, oh no. So at 0 it's 1, 1 it's 2. Well, actually let's work backwards, right? So 0 from the end, 0 from the end again for the second one. Then it's 0, 1, 2, 3, 4, 5, 6 for that one. Then it's, let's see, 5. Then this one, it's 5 as well. Then this one, it's 1, 2, 3, 4. Six. Then this is just 2, then 1, right? And this would be, so working backwards might work. So the idea is that we check here. When this is larger, then we record the index of the larger temperature here, such that if this number is smaller than, or if this number is larger than this, we can check the next one pretty much instantaneously. So the idea is like for this 71, right? For this 71, we will say, okay, the next one is smaller. How about the next of the next? So this would be plus 1. So if we did plus 1 with this number, then we get the number afterwards, right? And we know that the number afterwards is 76. Or rather, we know that the number here is 76. Or 72 rather, sorry. So 72. We know that it takes 1 day to go from here to here, from our next number to the actual number. And we can choose to either take that amount And we would pretty much, would we only choose that amount? If this was 71, no, then we would get the highest of here. If this was like a 70, right? If this was like a 70, then you would look at the next of the 69, which would be 70. We compare the 70's value. This is not good. Then we check the 70's value, and we increase our distance by 1. So now it's 2 plus whatever is at 70. And at 70, we have to go 1 more to get to 76. Well, 76 is smaller, or 76 is larger. So now we do 2 to get to 70, plus the additional 1 at 70 in order to get 76. I think that works. I think that works, but I'm really not sure whether or not that could be justified as O of n. I think it makes sense because like we're sort of like jumping through to the largest value, but I'm not sure. Because if we find our number, then that's fine. But if we don't find our number, we go to the next one. And what if, let's suppose that we have a strictly decreasing sequence. So 90, 80, 70. In this case, of course, the last number is going to be 0. And the second to last number is going to be 0. But what about the third last? Well, if the next number is smaller and the next number is 0, so let's label this A. We'll label U, or we'll label them A, B, and C, right? So if B is less than C, or B is greater than C, and A is greater than B, then it makes sense to say that A is also greater than C. And I think, therefore, if we encounter a next where the value in answer is 0, then we are also 0. So I think this answer will work as a linear time solution. Let me try to build up the pseudocode. So start from the back of the answer array. Check the next number from the current index. If less, then do this. If it's greater, then just set to 1, because 1 will for sure be our, if it's greater, if our next number is greater, we just set to 1, we don't need to worry about the rest. If it's less, if answer at next is equal to 0, set to 0, right? If the next answer that we have has no greater temperature, then we can set ours to 0 as well. We don't care about the rest. Otherwise, check the answer at next, or the DP at next, for the subsequent value, and repeat. So repeat this loop, basically. So the idea is that we check the DP next for the next value. And we'll check that number here. And we'll say that if it's less, then we will keep going again, unless it's 0. Otherwise, we just keep going. If it's greater, then we set to 1, or the index, or next index minus current index. Yeah, I think it's just next index minus current index. Because even here, let's say 75, right? The next value is 71, which has a greater value of 72. So 71 is less, but it has a greater value of 72. 72 is still less, but has a greater value of 76. And 76 is here, minus 4 is 75. So we always set it to the next index minus current index, and that's how we can get the answer. And so with this leapfrogging thing, it's just hard for me to justify that this is a linear runtime algorithm. It feels like it'll be faster, but I just don't know whether or not it'll be asymptotically faster to the point where it will be linear. My gut feeling says yes, because the idea is that if we find a larger number, we immediately cancel. And since we are not wasting our time with the intermediate values, then we can just skip those. Of course, dp of current index is equal to next index. So I want to say that this is an O of n solution, runtime solution, but I'm really not sure in terms of the justification for this. It just feels faster because we very likely will not be checking the next, because we will be checking the number that is larger than our next number. And it could be the one after that, or it could be way over at the end of the array. We don't know. It doesn't really matter for us because we're not traversing the whole thing. In terms of space, we're going to be running 2 DP arrays. Well, one intermediate DP array, and then the output array. It's up to you if you count those as if you count both of them, but it doesn't really matter. It's still linear space. In any case, let's go ahead and code this up then. Let's do a val int dp is equal to int array of size temperatures.size. And we know that temperature's length is, so if temperatures.size is equal to 1, we can just return int array of size 1. And this should return an int array with just 1, 0. I assume that the initialization for the int array is 0. Hope I don't need to do that initialization myself. And then we can say val answer is also an int array temperatures size. We can return answer here if I can type. Then we can say for index in answer dot size -1 down to 0 inclusive. We can say var next, or actually this should be answer size -2 because we don't care about the last value, right? So var next value, or next index, we'll say, is equal to index plus 1. We can say while our temperatures at our current index is less than our temperatures at our next index. So while they're less, otherwise, in this case, we can say answer at index is equal to next index minus index, and dp at index is equal to next index. Let me think about this, because we also need to consider if the answer next is equal to 0. We can say if answer at next index is 0, then we can say answer at index is equal to 0. And then we want to break out of this loop. But the problem is that how do we tell the program essentially that we don't want to set it here? Otherwise, well, we want to say next index is equal to dp at next index. And then we just want to continue from there. We can say var index or no index found is false. And we can say no index found is true. And we can wrap this around and say if not no index found. This is a little bit weird on the wording, but basically if we haven't found a 0, then we can safely assume that at this point, once we break out of this while loop, that we have found an appropriate index at next index. And so we'll set the values there, essentially. We can do a print line here, and we'll say current index is next index. We can say print line here, we can say found or answer is 0. We can't go further. Or we can say going to next index, which is dp at next index. And we'll print here, we'll say next temperature is temperature at next index at index next index. And yeah, so the idea is pretty simple. We go from the end, well, the second to last element. We'll check the next, we'll start by checking the next value. If it's less, then we will go either find the next index here by going to the dp logic, Or if the answer at the next index is 0, that means we are greater than our next index, and that next index has no greater value to check against. So that means we're done there. And so we break out of this loop. So, and then we just return answer at the end. So I think this seems to be fine. Temperature's index is greater than temperatures at next index. And if our next index is 0, otherwise do that. Let's go ahead and run our code. Oh, this should be temperatures. Yeah, temperatures for the print statement. So we start at index 7 of 8, right? So 0, 1, 2, 3, 4, 5, 6, 7. Wait, what? 0, 2, 3. Interesting. I don't know. That's the next index. Lol. And then we can say like print line, like current index is index. That makes it look better. So we current index 6. We check 7. Well, at 7 the answer is 0, so we can't go further. We go to 5, which is 72. We check the next one is 76. Okay, that's fine. We go down to 69. The next is index 5 at 72, which works. The current index is 3. The next index is 4. Well, 71 is larger than 69. But we can try the next of 69, which is 72. So going to next index, which is at 5. The next temperature is 72 at index 5, which is larger than 71. So then we can add it into our answer array. And then we go on to 75. 75, next index is 3, which is 71. Well, that doesn't work. Well, then we'll go to index 5, which is 72. Well, that doesn't work, so we'll go to index 6, which is 76, which does work. And we've essentially skipped out a bunch of these in the middle, so we've only really skipped out on 69, but we can skip out on a lot more if the numbers differences was a lot larger. Let's see. So I think that works. So let's go ahead and comment out these print statements. And let's go ahead and run a submit, and let's see where we are at. Ooh, we got a wrong answer. We are wrong on just that one result. Let's see. We are wrong on 0, 1, 2, 3, 4. So this 47 should be, the next one is not greater. So we go to 76. Interesting. Oh, this is while it's greater. Okay. So I think while greater than or equal to should fix that. Let's go ahead and run another submit. And there you go. So this is a dynamic programming solution to LeetCode number 739, daily temperatures. We decided to work backwards instead of working forwards, and that way we sort of get an idea with our dynamic programming array of the answers that lie ahead of us, rather than having to check them all. This kind of reminds me of that LeetCode easy problem that I had to look at the solution for, which was, it was like the string where you had the delimiter and you had to get rid of something. It's been a while since I've done that problem, but the idea for that was you did it backwards. I think that looking at something backwards sometimes does help. And I can think of a few other cases where that could have come up. For example, finding the lowest common ancestor of two nodes in a binary tree, not binary search tree, right? Rather than searching down at each subtree, we just check the ancestors instead. So we go find those nodes rather than finding, so we compare the ancestors versus comparing the trees. And some other things like that. But dynamic programming, I think, works really well in this situation, primarily because we can cut down on the additional work of having to check all the numbers ahead of us. We can just check the number that is the next greatest. And that works because we only care about the number of days until a warmer temperature, not the warmest temperature. Or like some other like optimization here. We just care about the next value, so we check the next value until we get to the end. So that's the solution. We use dynamic programming. We started from the end and moved to the beginning, checking if the temperature next to it is greater, then we're fine. Otherwise, we check that temperature's even greater amount until we hit either a point where we know that the rest of the array won't have any temperatures greater than it, or if we found a greater temperature, and then we can just return the difference from there. So, I hope you learned something, and I will see you for the next problem.